We continue our topic, use of differentiation, use of differentiation, differentiation of function f of s. Okay, to find inverse Laplace transform. So in that we have study what we study here. If Laplace transform of the function f of t, if Laplace transform of the function f of t is equal to f of s, okay, then Laplace transform of t raised to n f of t is equal to what? Is equal to negative 1 raised to n d raised to n upon ds raised to n f of s. Okay, so this is what use of differentiation of the function f of s. Okay, in previous lecture we have seen that this is the effect of multiplication of the function f of t. So similar way we can use here derivative of the function f of s to find inverse Laplace transform. So what is that meaning? So that is L inverse of the function f of s is equal to minus 1 by t L inverse of d by ds into the function f of s. Okay, so this is the formula we will use to find inverse Laplace transform of the function f of s. Okay, so let us see the problem. Let us see problem how to solve or how to find inverse Laplace transform by using this formula. We have already studied on yesterday. Okay, so let us see the more example based on this. So example, find the inverse Laplace transform. Find the inverse Laplace transform of the function 1 upon 2 log of 1 minus a square by s square. Okay, this is the problem and we have to find inverse Laplace transform of this function. Okay, let us see how to find the inverse Laplace transform of the given function. So what is the given to you? Given that function f of s is equal to 1 by 2 log of 1 minus a square by s square. Okay, this is your given function. Now we will use the differentiation of the function f of s to find inverse Laplace transform. So therefore we write using differentiation of the function f of s. Okay, f of s. So just use this. Therefore L inverse of the function f of s, your f of s is given to you, that is what? 1 upon 2 log of 1 minus a square by s square. We first write down the formula L inverse f of s, and this is equal to negative of 1 by t L inverse d by des f of s. Just write down f of s. Okay, now substitute f of s in the formula. So therefore L inverse of f of s is 1 by 2 log of 1 minus a square by s square. Okay, just close the bracket, and this equal to minus 1 by t L inverse of d by ds, and f of s is what? 1 by 2 log of 1 minus a square by s square. Okay, so just simplify, then take derivative. So 1 by 2 is constant, I'm taking outside, this is 1 by 2t. Okay, L inverse of d by ds. So write down log of, just cross multiply, this is s square minus a square by s square. Okay, so this equal to minus 1 by 2t, and L inverse of d by ds, L inverse of d by ds, then apply the property of logarithm. So this is log s square minus a square and minus log s square. Okay, now take derivative of this. This is equal to minus 1 by 2t L inverse of derivative, differentiate this is log x carried to 1 by x, but this is not x, this is the just log of s square minus a square. So we'll take derivative of this again, so that is 2s upon s square minus a square. Similarly, derivative of this, so this is s square, and in the numerator 2s. Okay, in the numerator 2s. So let us move to the next page, then write. So therefore L inverse of 1 by 2 log of, what is your function, 1 minus a square by s square, 1 minus a square by s square. Okay, and this is equal to negative of 1 by 2t L inverse, I'm taking 2 common, okay, from the both term. So this become what, here you will get 2. Okay, 2, then s upon s square minus a square minus 1s will cancel, so you will get only 1 upon s. Okay, just apply the inverse Laplace transform inside the bracket. So 2 and 2 will chew हो जाएगा. So this is what, negative of 1 upon t. Okay, and L inverse of, just write down, L inverse of s upon s square minus a square, and minus L inverse of 1 upon s. Okay, so this equal to minus 1 upon t, and what is the inverse of this? This is cos hyperbolic at, cos hyperbolic, because here minus sign, s square minus a, cos hyperbolic at, and minus, and inverse of 1 upon s is 1. So just write it in systematic way. So 1 upon t, 1 minus cos hyperbolic at. Okay, I'm multiplying minus sign inside the bracket, so this become 1 upon t, 1 minus cos hyperbolic at. So this is your required answer. I hope you understood this problem. So next example, find L inverse of, the function cot inverse of es plus 1. Okay, we have to find inverse Laplace transform of this function cot inverse of s plus 1. Let us see how to find. Inverse Laplace transform of this. So solution of this. So using differentiation of f of s, using differentiation of the function f of s. Okay, where f of s equal to what? Cot inverse of s plus 1. This is your function. Okay. So what is the formula for this? Therefore, your formula is L inverse of function f of s. Okay. And this is equal to negative of 1 by t L inverse of d by ds and f of s. This is your formula. Okay. Now substitute the values of the function f of s, or just you can say we substituting the function f of s. F of s is what? Cot inverse of s plus 1. So this is cot inverse of s plus 1. Okay. Now close the bracket, and this is equal to negative of 1 by t L inverse of d by ds. Your f of s is cot inverse of s plus 1. Now close the bracket. Now just differentiate this. So this equal to negative of 1 by t L inverse of derivative of this cot inverse derivative is negative of 1 upon 1 plus s plus 1 the whole square. Okay. And if I take derivative of this function again, you will get 1 into 1 and constant term 0. Okay. So just simplify, negative and negative get positive, 1 upon t, and L inverse of 1 upon 1 plus s plus 1 the whole square. Okay. Now applying shifting property over here. So this is 1 upon t, and 1 upon t e raised to minus t, and L inverse of 1 upon, this can be written as what? S square plus 1 square. Okay, there is no change. So, and this is equal to 1 upon t and e raised to minus t, and what is the inverse of this? That is sine t. Okay, this is sine t. So this is your required answer. I hope you understood this simple problem. Yes, please
Yes,
reply. Okay,
Yes, sir. Yes.
ठीक है. I
Yes,
hope
sir.
this topic is clear. Is this clear to all?
yeah, sir.
हाँ. चलिए, let us move for the next topic, and this is the one of the most important topic of your Laplace transform. Okay. अभी तक जिसने जितने पढ़े इनवर्स के रिलेटेड टॉपिक, उसमें से सबसे ज़्यादा इम्पोर्टेंट टॉपिक आपका कौन सा है जो अभी आप करेंगे? लेट अस स्टार्ट द नेक्स्ट टॉपिक, convolution theorem. So before starting the convolution theorem, we must know what is the convolution of two functions. Okay. So we first define the convolution. Convolution. Okay. What is the definition of convolution of two functions? Convolution means what? Twisting, or you can say coiling, or you can say winding together. मतलब क्या? कोई भी, मतलब कि वायर जो है वो इसमें लिपटा हुआ है, मतलब कि कॉइल हुआ है, रोटेट हुआ है, ट्विस्ट हुआ है, दैट इज कॉल्ड अ कन्वोल्यूशन. ओके. सो व्हाट इज द मैथमेटिकल डेफिनेशन? सो वी डिफाइन फर्स्ट definition. Okay. If f1t and f2t, f1t and f2t are any two functions, are any two functions, any two functions, then the integral, then the integral of the form, integral of the form, integration of limit 0 to t f1u f1u into f2 t minus u du is called, is called The convolution is called the convolution of the two functions f1t and f2t. So it's called the convolution of the function f1t and f2t. It is denoted by the symbol. It is denoted by f1 f1t asterisk f2t. Okay. Thus given by thus given by f1t asterisk f2t, and this equal to integration of limit 0 to t fu into f2 of t minus u du. Okay, so this is your convolution of two function f1 and f2t. Okay, this is the simple definition of convolution of function convolution of functions f1 and f2. Okay, so what is the convolution theorem? So we state the convolution theorem. Convolution theorem. So what is the statement of the convolution theorem? What is the statement? So we state the convolution theorem, and this is the one of the most important theorem in your Laplace transform. Okay, so if Laplace transform of the function f1t is equal to f1t is equal to capital F of s, and Laplace transform of the function f2t is equal to capital F2 of s, then the convolution theorem states that Laplace inverse of the functions f1s asterisk, or you can say into f2 of s, and this equal to integration of limit 0 to t f1u into f2 t minus u du, where L inverse of, or you can say where f1t is equal to L inverse of the function f1s, and f2t is equal to L inverse of the function f2s. Okay, so this is the statement of convolution theorem. This is the one of the most important theorem of your Laplace transform. Okay, I hope you understood what is the convolution and what is the convolution theorem. Examples. Okay, first problem we take. Find the inverse Laplace transform. Find the inverse Laplace transform of the function s square by s square and plus 2 square the whole square. Okay, we have to find inverse Laplace transform of this function. So let us start the solution. We first let the function f1 of s equal to what? S upon s square plus 2 square. Okay, because this is the square of square. Okay, this is what? S upon s square plus 2 square, the whole square. Okay, so we can write f1 s equal to s upon s square plus 2 square, and f2 of s is also same. f2 of s is what? S upon s square plus 2 square. Okay, so this is f1 of s and this is f2 of s. Now what I have to do? We have to find inverse Laplace transform of this function. So find, or you can say, then applying inverse Laplace transform on both sides, this is what? L inverse of f1 of s, and this is equal to L inverse of es upon es square plus 2 square. So this equal to what? Cos 2t, and this is equal to f1 of t. f1 of t. Say this function is f1 of t. Why is this so? Because cos is a function of t. So this is f1 of t. We taking the function f1 of s. So corresponding to this, we have inverse f1 of t, small f1 of t. Getting? Similarly, you will take L inverse of f2 of s, and this is equal to L inverse of same function s upon s square plus 2 square, and this is equal to what? Also cos 2t, and this function will be what? This function will be f2 of t. Say this is f2 of t. Okay, so we got function f1t and f2t. Okay, we got function f1t and f2t. Now use convolution theorem. Let us move for the next page. So using convolution theorem, using convolution theorem. What is the statement of convolution theorem? What is the statement? L inverse of f1 of s star, or you can say asterisk, f2 of s, and this is equal to integration of limit 0 to t f1 u into f2 t minus u and du. Okay, this is your convolution theorem. Therefore, we substitute the function f1, f2, just substitute. So therefore L inverse of f1 of s is what? S upon s square plus 2 square, and f2 of s is same, s upon s square plus 2 square. Okay, and this equal to integration of limit 0 to t. Okay, f1 u. Okay? Your f1 is what? This one. So instead of t, we write here u. So this becomes cos 2u. Cos 2u into f2 of t, f2 of t minus u. So we are replacing t by t minus u in the function f2t. So just replace cos 2 is the same, t replaced by t minus u, and du. Okay, so this can be written as what? So therefore we write L inverse of, so multiply together, so this become what? S square upon s square plus 2 square the whole square. Okay, and this is equal to integration of limit 0 to t. Okay, here I am multiplying 2 and divide 1 by 2. Okay, so this integral become 1 by 2 integration of limit 0 to t 2 times of cos 2u into cos 2 times of cos 2 times of t minus u du. Okay, so this equal to 1 by 2 as it is, integration of limit 0 to t as it is. Here we apply formula of 2 cos a into cos b. So what is the formula for 2 cos a into cos b? Yes, you know formula of 2 cos a into cos b.
Cos A plus B plus cos A minus B.
Yes, correct. So here we apply formula of 2 cos a into cos b. The formula is what? So this become cos a plus b. Cos a. A is what? A is your 2u cos a and plus b. B is this 2t minus u. Okay. Cos a plus b. Then plus here and cos a minus b. Cos a is 2u minus 2 times of b is t plus sorry t minus u. Okay, just close the bracket, and here write down du, and this equal to what? 1 by 2 integration of limit 0 to t. So before integrating we must simplify the bracket. So this is what? Cos 2u and plus 2 times of t minus 2 times of u and plus cos 2u minus 2 times of t minus minus get plus 2 times of u. Okay, close the bracket and big bracket also and du. So minus 2u and plus 2u cancel और यहाँ से कुछ नहीं. So this equal to what? 1 upon 2 integration of limit 0 to t your in the bracket cos 2t. Okay, and plus cos 2 2u and 2u, that is what? 4u and minus 2t. Just close the bracket and write down du. So let us integrate it. So this equal to 1 by 2. This equal to 1 by 2 big bracket. We are integrating with respect to u. So cos 2t is a constant. So we taking outside. So integration of limit 0 say t and du. Okay, and plus integration of limit 0 say t cos 4u minus 2t and du. Now close the bracket. So this equal to 1 by 2 open the bracket cos 2t into u. Okay, I'm not providing limit now, just integrate this first. So plus what is the integration of cos? Integration of cos is sine. Okay, sine 4u minus 2t. Okay, but divide by their coefficient. What is the coefficient of u? That is 4. Okay, by this so because we integrating with respect to u, and this is the constant, so there is no need of this, and providing limit 0 say t. Okay, so this equal to 1 by 2 upper limit, instead of u we putting t. So cos 2t into t upper limit and plus sine instead of u we putting t. So this is a 4t minus 2t and divide by what? 4. This is for upper limit minus lower limit. If I putting 0 instead of u, so this become what? 0. So 0. and plus sine instead of here u we putting 0, so this becomes 0, 0 minus 2t by 4. Okay, just close the bracket. So we simplify this. So this equal to 1 by 2 big bracket. So write it in systematic way, t into cos 2t, okay, and plus 1 by 4 sine 4t minus 2t, that is 2t, okay, and minus multiply inside here, minus here become what, sine negative of 2t and by 4, just close the bracket. Now let us move to the next page, then simplify it.
सर
हाँ
सर साइन जीरो सर कितना होता है?
हाँ,
साइन जीरो
साइन 0 0,
तो सर कॉस जीरो?
कॉस 0 1।
सर आपने जीरो लिखा है।
कहाँ लिखा है? ये देखिए बच्चा, यहाँ पे टी के प्लेस पे नहीं पुट कर रहा हूँ मैं, यू के प्लेस पे पुट कर रहा हूँ। ठीक है, यहाँ पे यू अगर 0 मल्टीप्लाई होगा तो पूरा टर्म 0 हो जाएगा ना, समझ में आ रहा है?
मतलब टी की जगह पे यू
टी
की
की जगह
जगह।
पे नहीं, यू के प्लेस पे पुट कर रहा हूँ, क्योंकि वी आर इंटीग्रेटिंग विथ रिस्पेक्ट टू यू ना। गॉट इट?
यस सर।
चलिए लेट अस मूव टू द नेक्स्ट पेज. So we will have L inverse of s square by s square plus 2 square the whole square, okay, and this is equal to, just copy from the next step, 1 by 2 t cos 2t, 1 by 2 t into cos 2t, okay, then 1 by 4 sin 2t plus sin 1 by 4 sin 2t, okay. So here minus sin minus theta equal to what, minus of sin theta, so minus sin एक बाहर आ जाएगा तो minus minus get plus here, so this become plus sin 2t by 4, sin 2t by 4. You understood? Yes or no? So this is what, since we write here sin minus theta equal to minus of sin theta, okay, because of this, okay. Now let us simplify this. So this equal to 1 by 2 t times of cos 2t and plus see here, this is the same as 2 times, so we write here 2 times of 1 by 4 into sin 2t, okay. So simplify it more, so 1 by 2 t into cos 2t and plus 1 by 2 sin 2t, 2 1 2 and 2 to the 4, so this is 1 by 2, okay. So just take LCM of this or cross multiply, so 1 by 2, okay, we cross multiplying here, so 2 times of t times of what, cos 2t and plus sine 2t, okay, and divide by 2, so this become 1 by 4 2t into cos 2t plus sine 2t, okay. So this is your final inverse Laplace transform of given function. I hope you understood this.
हाँ सर.
आसान था ये, कुछ दिक्कत नहीं इसमें, ठीक है. चलिए अभी नेक्स्ट टाइप का प्रॉब्लम करेंगे. नेक्स्ट टाइप का एग्जाम्पल नंबर, नेक्स्ट एग्जाम्पल, example, find the inverse Laplace transform, inverse Laplace transform of the function, inverse Laplace transform of the function 1 upon 1 upon s minus 2 and s plus 2 the whole square. Okay, let us see how to find the inverse Laplace transform of this function. Okay, uh, in similar way we will find. Okay, so solution of this. So we first write down the given function. So what is the given? Given that f of s is equal to 1 upon s minus 2, 1 upon s minus 2 in bracket s plus 2 the whole square. Okay, s plus 2 the whole square. So we first we first let first f1 of s equal to what? 1 upon first term we taking s minus 2. Okay, and f2 of s, f2 of s will be what? 1 upon s plus 2 the whole square. If you multiply you will get the original function. Okay, so now applying inverse Laplace transform on this function. So L inverse of f1 of s is equal to L inverse of 1 upon s minus 2. But what is the inverse of this? E raised to, here minus sign is there, s minus 2, so here will be 2t. Okay, name this function as f1 small f1t, small f1t. Say this is function f1t. Okay, uh, similarly apply the inverse Laplace transform on second function f2 of s, and this is equal to what? L inverse of 1 upon s plus 2 the whole square, applying here shifting property. So this become e raised to, plus sign is there, write down minus sign, minus 2t L inverse of 1 upon s square. So what is the inverse of 1 upon s square?
T.
T, simply t. Or this is what t raised to n minus 1 divided by n minus 1 factorial, but n is here 2. 2 minus 1, that is 1. T raised to 1 by 1 factorial. So simply it is t. So we write here inverse Laplace transform the whole thing. So e raised to minus 2t into t, and this is equal to function f2 of t. Say this function is f2 of t. Okay, this function is f2 of t. Now what is the next step? Your next step is use convolution theorem to find inverse Laplace transform of original function. Okay, so let us move to the next page first. So write down using convolution theorem, using convolution theorem, convolution theorem. Okay, what is the statement for convolution theorem? L inverse of f1 of s asterisk f2 of s, and this is equal to integration of limit 0 to t f1 of u into f2 of t minus u and du. Okay, so this is the statement of convolution theorem. Therefore we apply the convolution theorem. Okay, so we write L inverse f1 of s is what? 1 upon s minus 2. This is f1 of s. Okay, and into f2 of s is, f2 of s is what? What is the f2 of s function? s plus 2 the whole square. Okay, s plus 2 the whole square, just put in the bracket. Okay, so this is equal to integration of limit 0 to t. Okay, f1 of u, f1 of u we found here. The function f1 of t is what? E raised to 2t. Just replace t by u, replace t by u, so this become e raised to 2u. Okay, and into f2 of t, f2 of t is what? T minus u, so we replacing in the function f2t by t minus u. Okay, so your function f2t is what? This. So e raised to 2, we write here e raised to negative 2, and we replacing t by t minus u, t minus u into t also replaced by t minus u into t minus u, and write down du. Okay, write down du. Okay, so just simplify this. So therefore L inverse of, multiply together, so we will have 1 upon s minus 2 and s plus 2 the whole square. Okay, just close the bracket. So this equal to integration of limit 0 set t. Okay, e raised to 2u into e raised to, just multiply inside, minus 2t minus minus plus 2u into t minus u and du. Okay, so this equal to integration of limit 0 to t. See here base is same, so power will be added. So e raised to 2u minus 2t and plus 2u. Okay, into t minus u and du. So just simplify this. This equal to integration of limit 0 set t, e raised to 2u and 2u, that is 4u minus 2t. Okay, and into t minus u, t minus u du. Okay, t minus u du. Now what I have to do next step? So we are integrating with respect to u, so t will be constant, so we just break this. So what will the constant? E raised to minus 2t is constant, we taking outside. Integration of limit 0 set t, e raised to 4u into t minus u and du. Okay, now before integrating we just arrange the terms in Lie form. So Lie means what? L for logarithmic, A for algebraic. Lie form, L Lie. Okay, so L for logarithmic, I for inverse, and T stand for, sorry, L for logarithmic, I is inverse, A is algebraic, T is trigonometric, and E is exponential. So just observe this. Algebraic function come first and exponential later. So we interchange this. So this equal to e raised to minus 2t integration of limit 0 to t. So we are at t minus u and e raised to 4u, e raised to 4u and du. Okay, it's equal to, just integrate this. So e raised to minus 2t, e raised to minus 2t, we integrating, we are using here generalized integration by parts. So first this is this is u term, this is v term. Okay, so we write first term t minus u integration of v, integration of v is e raised to 4u and divide by its coefficient 4. Okay, and minus derivative of u, derivative of u is what? So derivative of t is 0, u is minus 1. Okay, minus 1 and integration of this. So e raised to 4u and divide by 4, but 4 is also here, 4 for the 16. Okay, just close the bracket and providing limit 0 से t, providing limit 0 से t. So this equal to e raised to minus 2t, big bracket, just simplify, then provide limit t minus u, okay, and e raised to 4u by 4, okay, minus minus goes plus, plus e raised to 4u by 16, and limit running from 0 to t. Okay, now let us move to the next page, then provide the limits of same. Okay, so the next page we move. So therefore we write L inverse of 1 upon s minus 2 s plus 2 the whole square. This is your function, this is your original function. Okay, and the next step is what? Previous step, e raised to minus 2t, e raised to minus 2t, and bracket t minus u, t minus u, t minus u e raised to 4u by 4, and plus sign is there, e raised to 4u by 16. Okay, plus e raised to 4u by 16, and limit running from where to where? 0 से t. Now providing limit, upper limit we providing first, so e raised to minus 2t, open bracket, this upper limit, so t minus, instead of u we putting t, so t minus t, and e raised to 4t by 4, okay, and plus e raised to 4t, instead of u we putting t by 16. Okay, this is for upper limit, minus lower limit, minus lower limit. So your lower limit is what? 0. So t, instead of u we putting 0, and e raised to 0 by 4, and plus e raised to 0 by 16. U, instead of u putting 0, so 0 multiplied by 4 is 0, so e raised to 0 is here. Okay, so just close the bracket and simplify this. So this is equal to e raised to minus 2t, and open the bracket, t minus t is 0, so 0 multiplied by anything is 0, and plus e raised to 4t by 16. Okay, and minus here, e raised to 0 is 1, so this become 1 by 4, or here t, so negative of t by 4, negative of t by 4, and this is minus and multiply inside the bracket, so here will be minus, e raised to 0 is 1, so this become minus 1 by 16, so minus 1 by 16. Okay, write in proper way, e raised to minus 2t. Okay, so e raised to 4t by 16, and minus t by 4, and minus 1 by 16. Okay, just take LCM, e raised to minus 2t, e raised to minus 2t, I'm taking LCM as a 16. Okay, 16 divided by 16, 1 multiplied by 1, so this become e raised to 4t. Okay, and minus 4 for the 16, and multiply by 4 with t, so this become 4t. Okay, and minus 16 divided by 16 is 1, and this become minus 1. Okay, so this equal to what? This equal to 1 by 16 e raised to minus 2t, and in bracket e raised to 4t minus 4t and minus 1. Okay, so this is your required inverse Laplace transform of the given function. I hope you understood, student.
Yes, sir.